Hello, my name is Joe Barth, team captain of Cyberdyne. Here I'm going to present the final submission for Neudesics IoT Innovation Challenge. I would like to thank everybody for giving me the ability to do this project. It was very challenging, fun, and then also in the end rewarding. I learned a lot about IoT. I learned a lot about coding Raspberry Pi, learning Node.js, Python, using all the things that we have in the cloud and Azure, giving us the ability to do what we can do with scaling up and scaling out. So let's review what we did. Intelligence in the cloud, a serviceless architecture with Azure, meaning using functions to trigger events. So we took Cortana and we said, hey, we used the Cortana channel and we said, hey, Cortana, start SQL drone, which is the bot, and that gave us the ability then to send commands to Azure Functions, write a command out to the SQL DB, and then the Raspberry Pi would look every couple seconds to take a command and say, hey, either take off or land, or then use a map A or map B. And so we're commanding the drone whatever we want it to do through the cloud. We have IoT Hub sending telemetry data as well. So I wanted to show you what we've done here. So this is my screen on my phone, and this is the Cortana channel. And what we did was we started up by saying start SQL drone and then take off. So that would send the command to take off the drone. And then you say tell it to land, and then it'll land. If we go back over here to the Power BI, and then we, like I said, that telemetry data was being piped through an IoT hub and pushed out to either Power BI, as you can see here, and then also Azure Data Lake Analytics, Data Lake Store as well. So that was our basic implementation. If we go on, and what we tried to do here with assisting was, why don't we bring in AI and say, hey, given certain data fields, can we predict something? And then in the innovation challenge, we took things that people have already done and we brought them together. And I think that was kind of the focus here in the end, is to take all the three micro challenges, self-updating and sensing, intelligence, and then assisting, and then bring them in together to make a proof of concept where an IoT device will end up helping you out somehow. And so self-updating and sensing, kind of remind you, we did Azure Facial Recognition API. So we sent a picture and it recognized that person and it took action. Intelligence, we added Azure SQL bot, Azure Q&A bot that we trained a knowledge base on, and it made decisions based on what input we gave, and we kept on training that model. And then in the end, the last 3 weeks, it came publicly available in Azure SQL DB to be able to do the predict function, or to have the ability to create a machine learning model and then do predictions. So we've added a sprinkle of that in there to make informed decisions on its own based on other IoT devices. And that's kind of what we're going to focus on showing you today. So we're going to say, hey, other drones took a certain map A or map B, and how long did it take them based on the factors like battery level and altitude. So that's really the innovation in assisting, is we have all these other devices to make decisions, and we take that data, push it through the Raspberry Pi, and send it to Azure Functions, and then also that writes out to the DB, and then we use machine learning. Okay, in order for me to show you the assisting machine learning part, what I need to do is actually generate data. And in order to do that, I've created an IoT generator application that's running constantly, and it's writing out records per second. As you can see, we're creating data for over 200,000 drones. We're writing out 17, 18, it can go up to whatever hundreds, thousands of records per second. It's doing that because everything in Azure SQL DB is in memory. So we're doing a temporal table in memory, which is really cool, leading edge. So that data right here is being generated, and we're going to show you what it looks like in the when we refresh the data here on the Power BI dashboard. So we have telemetry data, the consumption of electricity of what the electrical average measurement in what kilowatts that the drone is taking, and showing what areas in Seattle all 200,000 are. So you can see that the ability to connect to the cloud and use all the resources that we have, we can programmatically just dynamically create the dashboards that we need in real time or refresh rate, which is really cool. But this shows you that it's not just, we can even do other types of data, not just drone data. So it's really a great framework to work with for that. So if I go ahead and show you the code that's used to generate the predictive model. First, what we do is create a table to store that in the model. Then we take the decision tree model to generate time taken. We want to find out how long it's going to take a map, and we want to predict that. And so what I did was to take two factors, altitude and battery level, and that predicts time taken. Obviously, my data science isn't quite as good as the crew that we have for data analytics. So I'm going to work with them and create a better model for predictions, especially with drones. But this is very simplistic and straightforward, and I wanted to kind of show that you have the ability to do this within Azure SQL DB and the ecosystem that I've created. So we also then take and create a stored procedure that does the scoring. So once we train the model, now we can score. So this then takes data from the database, but at more of a level that we want to take it, and then it takes that in, and then we score the maps and say how long, what's our prediction on how long they're going to take to run, and so we got to choose which one's the fastest. So in order to do that, we do run the truncate table in insert that is being run every minute now from a Azure function, which is serviceless. It just is a timed function, C#, and we'll show you. But first, let's go ahead and look at the results. It looks like map 2 is the fastest right now. It was when I ran this, but we should be seeing a different time and a different map, unless map 2 is still the fastest. But it looks like map 1 has done its job. So if we go ahead and look at the function, it's just going to have the truncate table and the insert and the predict store procedure, and that's the serviceless part. So this can be changed programmatically on the fly through GitHub and continuous integration, which is really cool. So in ending, I want to just say, that this solution isn't just about drones. It's about IoT data for all. So when you ingest data through IoT Hub or any, you need a place to store it and work with it. So this ecosystem that we've created, it gives us the ability to use machine learning, and the new Azure SQL DB, you have to have at least a premium level. You can do the models just like in the SQL Server 2017. So that's what I showed, and that's the cysteine part. So it's going to help us decide which map to take and which one's the fastest. But the analytics platform for enterprise AI, this is a cool kind of overview, and this is where we're going. So the whole drone project got me going that direction, and so it was really cool that I was able to do this. I'd like to thank Ross Harrison and everybody who made it happen to be able to do the innovation challenge, and I had a great time. It was very fun, challenging, and rewarding. Thanks everybody, and have a great weekend.